CLO1.2, Organize and Interpret Data Using Frequency Distributions. Okay, as you may remember, LO1 is talking all about statistics, and statistics involves collecting data, organizing data, and summarizing data. This lesson is going to specifically focus on organizing data using tables. Okay, to start off, I want to just introduce some vocabulary words that we will use a lot. The first one is raw data. Raw data is the phrase we use to describe data that we collected, so all the information, all the answers to the survey questions that we collected, but we have not yet organized those answers. So they're not organized in any meaningful way. It's just a pile of survey answers. That's called raw data. Second vocab word we will use a lot is frequency. Frequency is the number of times that the same answer was given in a data set that we collected. Okay, and the last one is frequency distribution. This is the fancy way of saying make a table. A frequency distribution is just a table. Okay, so when we talk about frequency distributions, remember that's just a fancy way of saying a table. When we talk about making tables, there are two main types of tables we will be creating. One is called categorical, and this is when we have qualitative data. And if you remember, qualitative data is usually words or letters, but basically not numbers that you do math with. When you have qualitative data, we'll make categorical frequency distributions. And when we have quantitative data, we will make either grouped or ungrouped frequency distributions. Quantitative data, remember, is when we had survey questions where the answers we collected were numbers. We'll talk in the next slides what is the difference between grouped and ungrouped. But in general, the main two differences we will talk about is when the data we collected is words, we make categorical tables or categorical frequency distributions. And when the data we collected is numbers, we will make either grouped or ungrouped frequency distributions. And I will show you examples of all of those. So here's our first example. Imagine we did a survey and we asked people something simple. What is your favorite color? And you can see in the three boxes below, these are the answers that I collected to my very simple survey question. Now, as you can see, these words written out, they're words, they're not numbers. So categorical frequency distributions are when we have qualitative data that we collected, which is words. Okay, so we collected some words. As you can see, they're not organized at all. This could have just been the answers in the order that I collected them. So what we want to do, it's very hard to draw any conclusions when you just see a big pile of words. What we want to do is turn those into a table. So what we'll do is we'll look at all the possible answers. I see the answer red. I see the answer yellow. I see the answer green. I see the answer blue. So I just see those four different answers. So what we'll do is we'll make what's called four different classes. Another word for class is category. So, and then what we'll do is we will count how many answers were red, how many answers were blue, how many answers were green, how many answers were yellow. So red, 1, 2, 3, 4, 5, 6. When you make a tally table, you do 1, 2, 3, 4, 5 goes like this, so it's easy to count, and 6. And then we can just write the number 6. Okay. That was how many people said red was their favorite color. Let's look at yellow. No, blue is next in my classes, in my categories. 1, 2, 3. I think that's how many people said blue. And then green, how many people said green was their favorite color? 1, 2, 3, and 4. Okay, how many people said yellow was their favorite color? 1, 2. Okay, and what we want to do before we go any further, we want to make sure we didn't miss anything. And here's the quick technique to make sure you didn't miss anything. If you add up the entire frequency column, and by the way, the symbol for add is this Greek letter sigma. If you add up all the frequency column, that will equal the total number of answers or items in your survey. And so if we added 6 plus 3 plus 4 plus 2, we would get 15. We just want to double check and make sure that there were 15 different answers collected. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Check, we didn't miss anybody, we got it right. And now you can see this categorical frequency distribution, this table. It's a lot easier to draw conclusions than just looking at the unorganized pile of raw data that we were given. Remember, this is the raw data we were given. It's harder to make conclusions, especially if there's lots of raw data. But when we turn it into a frequency distribution or a table, then it's a lot easier to see, for example, red was the most popular color, yellow was the least popular color. Okay, so here is another example. In this example, imagine the survey question was, what was the maximum speed of students when driving to college today? So you can see I surveyed a lot of students and I got all the different maximum speeds they drove. So this would be an example where we have to make a grouped frequency distribution to organize all of this raw data. Again, raw data is the vocab word we use to describe the answers to our survey questions that have not yet been organized. As you can see, they're not organized in any way, small or big. It could just be the answer that or the order that I received the answers. Now, because there's so many different numbers, I cannot just make each one number be its own class. What I'm going to do is I'm going to group numbers together to make different classes. So what you want to do first in doing that is figure out the smallest answer in your data set and the largest answer in your data set. You want to make sure when you are creating your classes that you include both the smallest number and the largest number. Now for me, I like round numbers. I like to make it easy on myself. So if it was up to me, my instinct would be, okay, I know I need to include 67. So I would just start and say, how about 60 to 69 as a category? And then 70 to 79, 80 to 89, 90 to 99, 100 to 109. I have to keep going because I need to make sure that I include the highest number. So I'd have to go 110 to 119 and 120 to 129. So in order to follow the rules where I include every number in the data set, I would have to make 7 classes if I made the classes the way I just did. And a couple of things that are rules when you make tables. The first rule we already mentioned. We have to make sure all the data is included. Well, again, since 67 is the lowest and 125 is the highest, and I ended up starting at 60 and going to 129, all the data will be included. The second rule is that you have to have consistent class width. Now, what is class width? Class width is the difference that you traveled from the lower class limit of one row to the lower class limit of the next row. So to get from 60 to 70, I traveled 10. So the class width is 10. And you can see no matter which 2 rows you look at, the distance you traveled between the lower class limit and the upper class limit is always going to be 10. Those class widths have to stay consistent. That's a rule. And the third rule is that there cannot be any gaps between the classes. So if you notice, the upper class limit here is 69, and then the lower class limit of the very next row is 70. There's not any gap. A 79 is the upper class limit here in this row. The very next row, the upper class limit is 80. So there are not any gaps. So this would have been fine. I could go ahead and count all the different items and figure out the frequency in each class with 7 classes, 7 rows. So let's start with the 60s. There is only one item that is in the 60s, and that was 67. Let's move on to the 70s. I see 1, 2 in the 70s. Let's move on to the 80s. I see 5 that were in the 80s. Let's go to the 90s. 5 were in the 90s. Now in the 100s, I counted 11. 5, 6, 7, 8, 9, 10, 11. 11 were in the 100s. Now in the 110 and teens, I counted 3. And then lastly, in the 120s, I also counted 3. And if we want to make sure we didn't miss anything, we can always add up our frequency column. Remember, the sum of the frequency will give the total number of items in our survey or in our table. And when I add that all up, I get 30. Let's double check and make sure that's what it should be. 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5, 6. Yes, it should be 30. So we didn't miss anything. And now that the data is organized, we can see what was the most popular class of speeds, actually the most popular class of speeds category was 100 to 109. The least popular was 60 to 69. You can see a lot more and make more conclusions like this. And you may be wondering about this column called class boundaries. I'll talk about that more on the next slide. So the next slide is actually the same data, and the reason I did that is, I chose to make 7 rows, 7 classes. That seemed the easiest and the most logical to me, but sometimes you will be instructed how many rows you should use, and when that's the case, you have to do it a little bit differently. So we're going to do this same example as the previous slide, but now instead of doing 7 classes, I'll make 5 classes, which is a little bit more complicated. So here are the steps. Again, we start in the same way. We say, okay, the smallest piece of data is 67. The largest piece of data is 125. So we must make sure that all of that data is included in our classes. And since I'm not going to make it so simple as I did in the previous slide, going 60 to 69, 70 to 79, because that made too many classes. So there is a formula so we can decide how big to make each class, what the class width should be. So here's the formula. It says that the class width should be the range divided by the total number of classes you want to have in your table. So the range is the maximum minus the minimum. In our case, it's 125 minus 67. So in this case, it will be 58 divided by, we want 5 classes. So when we do that division, we get that the class width should be 11.6. Now we always want to make our tables as clean and pretty as we can, so we really don't want the class width to be a decimal. So you should always round up for class width. If you don't, then you will not meet the requirement of covering all of the data. So you must round up, and so our class width in this case is going to be 12. Even if we had gotten 11.1, we should have rounded up. We should round up and make the class width 12. So what we'll do now for the classes is we'll start at the smallest, 67. And to get to the next lower limit of the next row, the next class, we should add 12. So we'll add 12, 79. We'll add 12 again, 91. Remember, one of the rules, the class width has to be consistent for each row. This will be 103 when you add 12. This will be 115. Now, how do we decide the upper limits? Well, remember the other rule, we should not have gaps. So if the second row starts at 79, the first row should end at 78. If the third row starts at 91, the second row should end at 90. And so on. Since the fourth row is starting at 103, the third row should end at 102. And if you'll notice, each of these we are adding 12. Remember, the class width is consistent. So this will be 114, and this would be 126, which also meets the requirement because both the smallest and the largest data point will have a place to go. There are no gaps, and the class width is the same. Now the next column, I know I skipped it in the previous slide. Let's talk about it now. This idea of class boundaries. Do you remember that rule I said where there can be no gaps in the data, right? We went 67 to 78, and then the very next row it goes 79 to 90. But let's think about this for a moment. Speed is continuous data, meaning we are allowed to have decimals. So it's possible I could measure the speed of somebody and I could get a speed of 78.5, right? That's a very possible speed value. So the question is, if someone drove 78.5, would I put that answer, that survey answer, that data I collected, would I put that in the first row or the second row, right? The first row ends at 78, the second row starts at 79. So in fact, we broke one of my rules, which said there cannot be any gaps. So to solve that, we understand this concept called class boundaries. And the idea of class boundaries is related to rounding. So basically, on the left boundary, the lower limit, the left limit, all you need to do is subtract 0.5, and then it's going to go up to and less than the right limit or the upper limit plus 0.5. So for example, the boundaries in this case would be we will take any speed from 66.5 all the way up to and less than 78.5. So if someone went a speed 78.499999, that would still go in the first row. The moment they hit 78.5, we'd put them in the second row, and we will take any speed up to 90.5. That's the upper limit or this right limit, adding 0.5 to it. And again, it would go up to 90.499999, but the moment you hit 90.5 as a speed, it will be the third row, and this would be up to less than 102.5, and so on. This would be 102.5 up until less than 114.5, and this would be 114.5 up until less than 126.5. So the boundaries are there just to say, look, there really is no gap, and even if it's continuous data, every data point I collect will have a row in which it belongs. Okay, so we'll do this more quickly now. If the number is between 67 and 78, it will go in the first row. So I counted 3. And then now we're going between 79 and 90. I counted 5. Now we'll go 91 to 102. I counted 8. And now 103 to 114. I counted 9. And for the last class, 115 to 126, I counted 5. Let's double check, make sure I didn't miss anything. Remember, the sum of the frequencies is the total number of items, of data items. So when we add that up, we get 30, And I believe 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5, 6. That's correct, and should be 30, so we didn't miss anything. It's the same data, just organized into a table with 5 rows instead of 7 rows. Okay, now lastly we will talk about ungrouped frequency distributions. These are also for quantitative data, for numbers, but we can make ungrouped frequency distributions when the quantity of different answers we got is not too many. So in this case, the survey question was, what is the age of your dog? And these are the different answers we collected. There's not too many different answers, so each one answer can have its own class. So for example, I see the smallest age is 3, the largest is 9. So we can make our classes just have one item each in them. 3, 4, 5, 6, 7, 8, and 9. These are the different dog ages. There's no reason to group them into the same class. So we can have these 7 classes, and each dog age gets its own category, its own class. So very quickly, we will figure out the frequencies. How many dogs were aged 3? 1, 2. I just see 2. How many dogs were aged 4? 1, 2, 3, 4. 1, 2, 3, 4. How many dogs were aged 5? 1, 2, 3, 4. Also 4. How many dogs were aged 6? I just see 1. And how many dogs were aged 7? Let's get a new color. 1, 2, 3, 4. How many dogs were aged 8? 1, 2, 3. And lastly, how many dogs were aged 9? I see 2. Now, it's very easy to miss things, so it's a good idea always to add up your frequency and make sure that the sum of the frequency is the correct number. When you add all this up, 10, 15, 20, let's make sure 1, 2, 3, 4 by 1, 2, 3, 4, 5. Correct. In the raw data, we had 20 pieces of raw data. Okay, this next slide is the exact same set of data, and here's some different ways we might ask you questions about the data we collected. So let me pull up that frequency distribution, that table I already made. There it is. And the first question says, well, what's the least popular dog age? If you look at the frequencies, the dog age with the smallest frequency is the least popular. So I see that only one dog was aged 6, so the least popular dog age was 6 years old. The most popular, or the most common, you'll find out in future lessons that is called the mode, but the most common dog age, there was a tie. There were several different dog ages that all had 4 different dogs with those ages. So the ages 4 and 5 and 7 were the most popular ages of these dogs. How many dogs are at most 5 years old? Now this is an interesting English question. At most. At most means it could have been 3 years old, 4 years old, or 5 years old. So we're talking about these dogs. Not any more than 5 years old. The highest age they could be is 5. So you would add up 2 dogs plus 4 dogs in the second row plus another 4 dogs. That's 10 dogs were at most 5 years old. How many dogs were at least 5 years old? Again, this is an English exercise. At least 5 years old means 5 years old. Let me erase this. 5 years old or more. So again, we can include age 5. It could have been 5 years old or more than 5 years old. So that would be 4 dogs plus 1 dog plus 4 dogs plus 3 dogs plus 2 dogs. So that is 14 dogs. Okay, one more concept I want to share with you. We'll use it more in future lessons, but I think it's important to teach here also, is the idea of making another column in your frequency distribution called a cumulative frequency column. So here is how you create a cumulative frequency column. We will use it more in the next lessons, but it's important to learn from now. So the way you make a cumulative frequency column is you start off with the first frequency, 2. And what that means in the cumulative frequency column is that 2 dogs are in this category. And then to get the next entry, you add the next frequency. So 2 plus 4 is 6. And what that means is that 6 dogs are in the first 2 categories. And then you add the next frequency. 6 plus 4 is 10 dogs are in the first 3 categories total. Okay, you add the next frequency, 10 plus 1, 11 dogs are within the first 4 categories. 11 plus 4 is 15 dogs are within the first, I guess that's 5 rows, 5 classes now. 15 plus 3 is 18 dogs. And then lastly, 18 plus 2 is 20 dogs total. When you get to the end of the cumulative frequency, that will always equal the total number of answers or items that you collected in your survey. That's the cumulative frequency column. Okay, let's finish by doing a quick review of all that we've learned in CLO1.2. So the first thing we talked about is the 3 different types of frequency distributions. And if you remember, the phrase frequency distribution is just a fancy way of saying table. So you see 3 different tables here. And we first said there's 2 different types. There's categorical, and then there's grouped and ungrouped. Categorical deals with words. So this table on the right would be categorical because the data we collected, we call that X, it must have been the survey question, what is your highest level of education? And these are the number of people that answered. So we collected words. It was high school, bachelor's, MBA, so we use a categorical frequency distribution. Now in these 2 tables, the data we collected is numbers. However, on the left, we just have 1 number in each row, so that is called ungrouped. It's an ungrouped frequency distribution. The one in the middle, the data we collected is numbers, but each number cannot have its own row. We need a group of numbers in each row, so this would be called a grouped frequency distribution. So here are many examples of different things we might ask you about frequency distributions. As you can see on the right, we have a grouped frequency distribution because the data we collected is a group of numbers. So here is the data we collected, here is the frequency. Let's answer these questions. How many classes are there? Classes, remember, are rows. How many different categories? Looks like we have 7. What is the class width? The class width, if you remember, it's the distance you travel from one row to the next. So 31 to 41, the class width is 10. And this should be consistent between any 2 boundaries. How many total students were there? We just add up the frequencies to get the total number in this survey. In this case, when you add up all the frequency numbers, you would get a total of 31 students in this class or in this survey. What are the class boundaries? Now remember, class boundaries are there to make sure there are no gaps. So for example, if someone scored 40.2 on his test, we would need to know where to put him in which row. So the way you do the class boundary is you take the leftmost data point in that row in that class and you subtract 0.5. And then you take the rightmost data point and you add 0.5. So for the first row, it would be 30.5 up until 40.5. Then it asks what was the most common class of scores. So I will look here and see the most students answered or received a score in the range 71 to 80. The fewest students received a score in the range of 31 to 40. That was the least common range of scores. The cumulative frequency column. Okay, so to create the cumulative frequency column, we go to the right of our table and make another column. We'll call it CF for cumulative frequency. And you start with the same number that is in the top of the frequency column, 1. Then you add the number that's in the next row. 1 plus 2 is 3. That means in the first 2 rows total there are 3 people. Then you add the frequency in the next row. 3 plus 3 is 6. In the first 3 rows there are 6 people total. 6 plus 6 is 12. In the first 4 rows there are 12 people total. 12 plus 10 is 22. In the first 5 rows there are 22 total people. Then we add 5 is 27. And then when we get to the last row, we add 4, that's 31. And the number in the final row of the cumulative frequency column should match the number of people or items of data that we collected. So that's the cumulative frequency column. We will use that more in the next lessons. Let's answer a few more questions that they might ask. Here it says, how many students scored at most 60? At most means it could be less than or equal to 60. 60 is the max. So that is the people in the first 3 rows, which is 1 plus 2 plus 3 people is a total of 6 people. 6 people scored at most 60. It means they scored 60 or below. Let's answer the last question. How many students scored at least 81? That means they scored either 81 or more. So that would be the people in these last 2 rows. Those 5 people plus those 4 people. So there were 9 people that scored at least 81. Those are examples of questions that they might ask you having to do with grouped frequency distributions. Okay, and I thought we would practice one more time creating a frequency distribution when we are given a whole bunch of numbers and we need to put them in a specific number of classes. So the first thing you want to do in this case is look at all your raw data and find the smallest data point and the largest data point. We need to make sure that our classes include every number from that small one up through the big one. So here's the formula we have to use. We need to find the class width. So what we do to do that is we take the range, 110 minus 54, and we divide by the number of classes we want, in this case 6. So we will get, when we do that calculation, a class width that says 9.3. Of course we don't want decimals, so we will always round up. So we will make the class width 10. How do we do that? We start, let me change colors, we will start with the smallest data point that we collected, 54, and the class width says for each new boundary on the next class, we will add 10. So this will be 64, 74, 84, 94, 104, and 114. And I don't think we're going to need that last row. We only need 6 rows. And then how do we decide the upper bound in each class? What we do is we look, well, the second class starts at 64, so this one must go all the way through 63. The third class starts at 74, so this one must go through 73. And in each case, we add 10. So we will have 83, then we start at 84 up until 93, then we go 94 up until 103, and then 104 up until 113. So we have the class widths are consistent for each row. We have no gaps, and we have all the numbers included. So then we have to go through row by row and count the number of items in each row that we created. In the first row, 54 to 63, I counted 7 data points. In the next row, which will be 64 to 73, I also counted 7 data points. In the third row, 74 to 83, I counted 5 data points. In the next row, 84 to 93, I counted 5 data points, but when I was doing that, I realized I missed some in the previous row. I missed these 2. So I'm going to change this to also be 7. Don't worry, we will check at the end and make sure we didn't miss anything. Okay, in the 5th row, 94 to 103, I counted just 2 data points, and in the final row, which is 104 to 113, I counted also 2 data points. Now for the moment of truth, make sure I did it accurately. If you add up the frequency column, you should get the total number of raw data points. So when we add all this up, we get 30. Let's see if that's correct. 1, 2, 3 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is 30, so we didn't miss anything. Now the data is more organized. It has 6 classes like they told us to have, and there are no gaps, and the class width is the same for each. So there we go.